So hello everyone, in this video we are going to see the LTCT meters and how to test the accuracy of this meter, which is part of the LTCT metering system. So or LTCT meters, the connection will be like this. The meter terminal connection will be like this. We have R phase here, and this is S1 S2 of R phase, S1 S2 of Y phase, S1 S2 of B phase, S1 S2 of neutral, and this R Y B neutral voltages. Okay, the connection will be like this, and I'll show you the meter, how the meter looks like. See, this is a LTCT meter where the voltage is our domestic voltage only to 30 volt voltage. And then see, this is S1 of R phase, S2 of R phase, and then S1 of Y phase, S2 of Y phase, S1 of B phase, S2 of B phase, S1 of neutral, S2 of neutral, and these are the R, Y, B and neutral voltages. So this is an example of an LTCT meter, which is part of the LTCT metering system, and the meter is like this. You can see there the meter ratio is actually 100. Is it 100? No, it's not 100. It's a 1 only, not like the HT meter. So the accuracy class of this is 0.5s, and mind you that this is a three-phase meter. So for testing, you may think that okay, three-phase power supply is required, but you can, if you don't have that in your home, then still you can test the accuracy of this using a single-phase power supply, like in this case. So this is the phase, for example, this is the neutral, and then we can connect the three-phase, the LTCT meter like this. Okay, and you can connect it like this. You can loop this is inside the meter, and then loop like this. Okay, loop like this to Y phase and loop to B phase like this, and then you connect the load here. Load may be a heater, which is 1000 watt or 1 kilowatt heater, because you have to see that the secondary or the current rating of this is 5 ampere. All right, you can see it is 5 ampere, right? 5 ampere, and you see there the rated current of this is dash by 5 ampere. It can go up to maximum of 10 ampere, twice of Bmax. All right, 10 ampere. So if you want to test this, then in order to get 5 ampere, you can use a 100 watt heater. Then if you calculate the current, you will get around 3.89 something, 3.89 ampere, which is good enough for you to test the meter. And the connection will be like this, because how you calculate the resistance is you take the P voltage, you take V square divided by P. In that case, you will get the current. All right, so the connection will be like this. I think it is understood. And then now see, I have I'm showing here the R phase CT, the clamp CT that of the Accu check, that we clamp like this with the correct polarity, and if it is not correct also it will show. All right, and Y phase, the clamp will be like this, and in B phase you clamp this and go to the Accu check. And then the PT supply you can take from anywhere. The PT supply to the Accu check you can take from here also, because you only need RYB PT to Accu check, and then the neutral you can take from here. All right, so that's complete the connection to the Accu check. And then the pulse snap you can connect to the respective snap hole, and then connect to the LED of the meter for testing the accuracy, the active power. You can do for reactive power also, but this is how we calculate. All right, now this is the connection, and this is the meter. I have already shown you the meter will be like this. All LTCT meters will be like this. I will show you how the connection is done. We will go to the actual testing using the Accu check. All right, and we'll measure the accuracy. How much is the accuracy? So this is 0.5s. That means the accuracy class of this that the Accu check measures should be less than 0.5. You get 0.23, 0.24%. That's good enough. I mean the percentage error. All right, because what is the error actually? What is the error of the meter is the EM minus ES divided by ES, like that. Okay, the energy recorded by the meter under test minus by the standard, the reference, which is the Accu check only, divided by the standard of the Accu check. All right, so we're going to now see the real testing now. All right, how it is done live. So the connection has been done this way. All right, now the Accu check is ready. I have done the connection, and as per the one that I showed you in the drawing only, it will be like this. All right, now I'm using this single phase power source only to test the accuracy of this meter, and the pulse knob I have to properly make it kiss the active power LED like this. Okay, now once that is done, I will test this. Okay, I will on the power source. Now it will blink. All right, it should blink. After doing the connection like that, and then you have properly put the LED snap there, and then you can on the Accu check. All right, now once the Accu check is on, then I think the LED will also blink. All right, this you can give me, since we're using clumsity, so I'll press 2 for clumsity. 2. Is the connection okay? Yes, I'll press 1 and then wait. Okay, voltages, everything looks okay. Over voltage there is no issue, over current there is no issue, phase sequence also it's right, so I'll enter. And then the pulse rate, this is the standard pulse of this of the Accu check, which is 160 for every kWh, which is okay. And see the voltages, because I'm using the single source only, so the voltages will be identical, 248, 248, 248. And the power factor is, because it's active power only, the frequency is there, and the time will keep on running like this. Okay, and then it's ready. I'll just check the meter number is MS5002167. Is it okay? It's all right. And then the constant ID of this Accu check is 6400, which is okay. And then the MT constant, meter constant, is 16,000, which is okay. 16,000 only. And then after this will be your E-type. This is not required, you can keep pressing. And then the revolution, how much you want, because it seems to be blinking very fast, so it's all right, seems to be blinking very fast. So I will do like this. I will make it 500, which is already made there. And then CT ratio is also 1. And then mode, since I'm using a pulse snap, so I'll press 1 0 0. All right, now I'll press enter, and then I will start. It's ready. Scanner, it's scanner. See, now it's going. All right, now the test is going on. See the snap there, it will also blink the snap. All right, the connection looks okay. See, this bulb is actually for its indicator. It's an indicator only, that's the voltage is there. And this is my load, which is a 1000 watt or 1 kilowatt. All right, the connection is this. I have set 500 because it looks very fast. Doesn't work properly because of the external light. I'll have to close the door. I will run the test again, because I was opening, the door was open, and then because it's actually based on the lights. I mean the testing is based on the LED impulse. It could not detect because of external light, so I will close the door. I've already closed, and then I'll run the test again. So let me on this. All right, now I'll run the test again. I'll run the test again. right. You should you should blink like this because external light is not there, so it's blinking. Whatever it blinks. So this is the percentage error, which is minus 0.35, which is less than 0.5 s. Alright, so this is how we have tested the accuracy of this meter, which looks fine, looks okay. So the complaint by the consumer doesn't stand, and we have already tested, and the Accu check shows that it is actually less than 0.5. So the meter is still okay, it can be declared okay, it will not be replaced. Alright, so this completes the testing procedure. And how do you test the LTCT meter using a single phase power supply at home, which you normally have only single phase. And if you have three phase, that's good enough, but if you can do it using single phase, then why to waste time, because in three phase connection, the connection will be a little more and you have to do lots of connection. All right, so this is how you test the meter. All right, so thank you.